Hello, I'm Zihao Wang, an exchange student studying in University of California, Berkeley for my senior year. And in my first 3 years of university life, I studied in Beijing Institute of Technology in China. And in this video, it will be divided into 4 parts. In the first and the second parts, it tells you my exoskeleton systems. And in the third part, it tells you my pneumatical balloon caster designed in UC Berkeley. And in the last part, it is about my climb robot designed in my freshman year. Firstly, here is the chest expanding exercise. You could imagine what your chest feels when you put on it. Secondly, here is the kick motion, which would counteract the muscle of leg in order to make you more strong. And because the hard shell robot is a half-size model, I express the condition by 3-dimensional software when people put on it. In the flesh, as we can see, compared the traditional fitness equipment, the hard shell robot is an integration of lots of fitness equipment. You couldn't change the equipment to exercise different muscles of the body, and you could exercise both arms and legs in the robot at the same time.
然后这款机器是不是样子很独特？它也是机器人吗？
最初灵感来源其实来自于好莱坞的电影，比如说钢铁侠，比如说阿凡达，在那里面我们就看见了人穿戴在一个机械里面，然后可以帮助人去进行锻炼，或者说进行助力的一个动作。我们这里呢是一个穿戴式的健身器和康复仪。如果说它放大1倍的时候，您就可以穿戴在里面进行各种健身锻炼和康复牵引的一些锻炼。传统的健身器材，我们知道占地非常的大，说锻炼不同的肌肉部分的时候，你都得从这个机子下来到另外一个机子上上去。但是它我们知道就不用，因为它是一体性，穿戴在里面，它有一个同时性锻炼的一个好处。
Well, next I will introduce you the exoskeleton power assisting system. It is the second generation of exoskeleton fitness equipment system, with improvements in terms of power, mechanical structure, and control. It used a combined power supply of air cylinder and electric power passion for a lower cost and higher power than stable motors. It also added a third degree of freedom to the arm through a 3 RPI structure at the shoulders and assembling planar carriers at the forearm and upper arm to simulate rotation about the wrist. It is also using sensors deployed in different parts of the body to sense the tendency of movement and follow of the movement in the body. Thirdly, it is the balloon caster project. I and 3 American students modeled and designed a braid-shaped medicine-eluting balloon caster with nylon polymer by SolidWorks and Ansys. The climb robot was invented in my first year of university life. It isn't a huge robot, but it is interesting. I believe you have seen snake in our nature. As we know, snake is a flexible animal and it could shift its shape to adapt to various environments. And at that time, the feature of the snake reminded me to invent a robot that could catch stick firmly and that could climb swiftly. Here is the climb robot. There are 7 steering engines in the body. The 7 engines make the robot go forward in 3 methods. Method 1 is the creep method. In this way, the robot uses the middle 3 engines to creep. Secondly, the method is called the stretch reversal method. The method makes the robot reverse directly to go a height, and there are 4 steps. That is step 1, step 2, step 3, step 4.